So today we are going to discuss again one important topic for your board exam. It is in icse board also, cbse board also, and in jack board. So this one is refraction of light. So first we are going to define what is refraction. So the phenomena of change of direction of path of light when it passes from one transparent medium to another. So what is the meaning of this? Whenever light is passes from one medium to another medium, then it is going to deviate from its path. Like in example, let's take this one is one glass. Okay, so glass is one medium, and here it is air. So air is also act as a medium. So let's see here one light ray which is falling on the glass slab. Okay, so when it fall on the glass slab, actually it should move in a straight line. This one is the path of the light ray. Okay, but it is not going to move in its actual path. It is going to deviate from its path. Now it's instead of going in a straight line, it is going to deviate from its path, and it will go like this. So this one is the deviation of path of the light ray. Okay, so this type of phenomena is called refraction of light. Instead of glass, suppose here there is water, then also this light is going to deviate from its path. Okay, now there are two cases when refraction will take place. Okay, see this light ray, here I have mentioned one light ray now. So this light ray, whether it will bend towards the normal, actually this one is our what, normal. Okay, so here I have shown in figure that the light ray, after refraction, it has bent towards the normal. It has bent towards the normal. There is two cases, either it will bend towards the normal or it will bend away from the normal. So it will depend on the medium through which light is coming. Okay, so there are two cases. So let's discuss case 1. In case 1, when light when light ray when light ray passes from rarer medium to denser medium. Okay, one thing I have told you that I have written here rarer medium and denser medium. Okay, so denser medium means actually the medium in which speed of light is going to decrease, so that one is act as a denser medium. Like here there is glass, so when light entered into the glass, its speed is going to decrease. So compared to this air, we consider this glass as a denser medium. So let's discuss case 1, when light ray passes from rarer medium to denser medium. So let's take an example. Suppose there is two medium, one side there is water and one side there is air. Okay, so this side air and here it is water. Let's draw one normal. Now suppose there is one light ray which is falling on this interface of the air and water. Okay, so air is which medium, rarer medium, and water is what, denser medium. So in this case, when light ray coming from rarer medium to denser medium, it will bend towards the normal after reflection. So what will happen? Refracted ray bends towards the normal. So here it will bend like this. So this one is first case. Now let's discuss case 2. Okay, so in case 2, when light ray passes from denser medium to rarer medium. So in this case, now light rays passes from denser medium to rarer medium. So let's take an example. Suppose again here there is water and air. So this side water and here it is air. Okay, let's draw one normal. Now in this case, what will happen? The light ray is coming from denser medium. Previously light ray is coming from rarer medium, so here light ray is coming from denser medium. So there is water and this side air. So when light ray come out from the water, so in this case this water is what? Denser medium, and air is what? Rarer medium. Okay, so in this case what will happen? The light will bend away from the normal. It will bend away from the normal. Okay, so this one is second case. So what will happen? Light will bend away from the normal after refraction. Okay, so two cases we have discussed, that when light ray is coming from rarer medium to denser medium, after refraction the refracted light will bend towards the normal. Here there is one case. Okay, now second we have discussed that when light ray is coming from light rays coming from denser medium to rarer medium. So in this case what will happen? The light will after refraction light will move or bend away from the normal. Okay, now one more concept is here, that one we have to discuss. That one is critical angle. Okay, and this one is very important, critical angle. Okay, so let's discuss what is critical angle. So first let's explain one thing. Suppose here one side there is water and this side there is air. Okay, so air and water interface is there. Draw one normal. Okay, now let's one light ray is coming and fall on this air water interface. So water is denser medium and air is rarer medium. So now in this case, light ray is coming from denser medium to rarer medium, and I have told you that when light ray will come from denser medium to rarer medium, it will bend away from the normal. So in this case, what will happen? Instead of going in a straight path, it will bend away from the normal. Okay, now let's increase this incident angle. As we know that this angle is called what? Incident angle. Okay, so let's increase this incident angle. Okay, so now in second case, light ray fall like that. So what will happen? Now this refracted light ray will bend more like this. Okay, now again suppose I increase this incident ray. Suppose now incident ray is like this. So we have increased the incident angle. So one angle will come, this incident angle, okay, at which this light ray will pass through this interface. Okay, means when we are going to increase this incident angle, जैसे first case में this one is incident angle, now second case this one is incident angle, in third case this one is incident angle. Okay, so एक इंसिडेंट एंगल का वैल्यू ऐसा आएगा, ठीक है, जिस टाइम में जो मेरा रिफ्रैक्टेड लाइट रे है वो डायरेक्ट इंटरफेस से होके पास करेगा, ठीक है, जो मेरा सरफेस को डिवाइड कर रहा है, रेयर और डेंसर मीडियम को जो डिवाइड कर रहा है, उस इंटरफेस से मेरा जो रिफ्रैक्टेड रे है वो पास होगा, ठीक है, क्योंकि जैसे जैसे हम इंसिडेंट एंगल को बढ़ा रहे हैं, मेरा जो रिफ्रैक्टेड लाइट है वो नॉर्मल से दूर होता जा रहा है, ठीक है, तो एक कंडीशन ऐसा आएगा जब ये इस इंटरफेस से पास करेगा, ठीक है, तो उस टाइम में जो मेरा रिफ्रैक्टेड एंगल होगा वो कितना हो जाएगा? 90 डिग्री, बिकॉज दिस वन इज refracted ray. Okay, so angle between normal and refracted ray is called what? Refracted angle. Okay, so refracted angle कितना हो गया? 90 डिग्री. Okay, so इंसिडेंट एंगल का वो वैल्यू, ठीक है, मीन्स सपोज दिस वन इज इंसिडेंट एंगल, इसको मान लो IC, ठीक है, दिस वन, सो इंसिडेंट एंगल का वो वैल्यू, ठीक है, जिसमें मेरा जो रिफ्रैक्टेड एंगल है रेयर मीडियम में वो कितना हो जाए? 90 डिग्री. ओके, उस एंगल को हम लोग बोलते हैं क्रिटिकल एंगल. ओके, सो वन थिंग नोट दैट. ओके, फर्स्ट वन इज व्हाट? critical angle. Okay, in some book it is represented by C, okay, or IC. Okay, so critical angle is incident angle. Okay, it is a special incident angle. Okay, for which the value of refracted angle in rarer medium become 90 degree. Okay, so that angle is called critical angle. So that one is the definition of critical angle. Now अगर if ये जो क्रिटिकल एंगल है इससे अगर हम थोड़ा सा भी जो मेरा इंसिडेंट एंगल है उसका वैल्यू अगर थोड़ा सा भी इंक्रीज कर देंगे, मतलब अगर लाइट रे ऐसे पास कराएंगे यहाँ से, ठीक है, तब इस केस में क्या होगा? मेरा टोटल इंटरनल रिफ्लेक्शन, ठीक है, मतलब लाइट रे मेरा सेम मीडियम में वापस चला जाएगा, ठीक है, सो दैट वन इज कॉल्ड टोटल इंटरनल रिफ्लेक्शन. ओके, सो टू कॉन्सेप्ट वी हैव डिस्कस्ड हियर. ओके, फर्स्ट वन इज व्हाट? discuss critical angle. So critical angle means what? The value of angle of incidence, okay, for which this one is refracted ray and this one is called refracted angle. Okay, it will become 90 degree. Okay, so that time it is called critical angle. Okay, so the value of incident angle for which the value of refracted angle will become 90 degree, so that one is called critical angle. And we have discussed one more thing, that one is total internal reflection. Total internal reflection. So what is total internal reflection? Total internal reflection means, suppose this one, oh, suppose this one is our incident ray, and this incident angle is what? Equal to critical angle. Okay, so in this case what will happen? This light ray will pass like this, okay, through the interface, making 90 degree. Now I have increased the incident angle. Now this one is our new incident angle. Okay, so in this case what will happen? I have told you that whenever the light ray fall on any surface, okay, greater than critical angle, then it will show total internal reflection. So this one is, this light ray will pass through same medium by making same angle. Suppose this angle and this angle, okay, these both angle are going to equal. Suppose this one is angle 1, this one is angle 2, so angle 1 is equal to angle 2, so it will follow the reflection law. So that one is called total internal reflection. Okay, so in exam sometimes they will ask some question. Okay, so that one is what are the condition for total internal reflection? Means total internal reflection का फिनोमेना कब हो सकता है? सो व्हाट वी हैव ऑब्जर्व दैट जो मेरा लाइट रे है वो किस में पास होना चाहिए? हमेशा डेंसर मीडियम से रेयर मीडियम में आना चाहिए, तब ये टोटल इंटरनल रिफ्लेक्शन होगा। क्योंकि अगर लाइट रे रेयर से डेंसर में आएगा तब क्या होगा? ये नॉर्मल की ओर जाएगा। ठीक है, जैसे जैसे हम ये एंगल इंक्रीज करेंगे इसका जो रिफ्लेक्टेड लाइट है वो नॉर्मल की तरफ आता जाएगा। ठीक है, बट अगर मेरा लाइट रे डेंसर मीडियम से रेयर मीडियम में जाएगा तो क्या होगा? ये नॉर्मल के दूर भागते जाएगा। ठीक है, नॉर्मल से और डिस्टेंस बनाते जाएगा ये एंगल। ठीक है, तो इसीलिए जब ये नॉर्मल से दूर जाएगा तब ये क्रिटिकल एंगल आएगा। ठीक है, और क्रिटिकल एंगल से ज़्यादा होने पे टोटल इंटरनल रिफ्लेक्शन। सो देयर इज टू कंडीशन फॉर टोटल इंटरनल रिफ्लेक्शन. So first one is what? The light ray should passes from denser medium to rarer medium, and second case is what? The angle of incident should greater than critical angle. Okay, so now let's discuss laws of refraction. Okay, so there is two laws of refraction. First law says that the incident ray, refracted ray and normal all lies in same plane. Okay, it is same as laws of reflection. Okay, then the sine of angle of incidence, sine I means what? Angle of incidence. Okay, so the sine of angle of incidence, okay, divided by sine of angle of refraction. Okay, so the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This one is second law. So sine I by sine R is written as mu 1 2, or simply it can write mu. This one is called mu, and this mu is called refractive index. Okay, here I have written mu 1 mu 2. So what is it is read as like that. See the number which is written last here 2 I have written now. So it is the refractive index of medium 2 with respect to 1. So it can be read like that: refractive index of medium 2 with respect to medium 1. Okay, so whatever is written in last, okay, we are finding the refractive index of that medium with respect to first one. So it is, suppose, see here I have written 2 mu 1. Okay, so it will read like that: refractive index of medium 1 with respect to medium 2. Some key point you have to remember that in refraction, whenever there is refraction, which quantity like velocity of light, wavelength of light and frequency of light. Okay, so out of these three parameter, which is going to increase, decrease, or which is going to remain unchanged. Okay, so when light passes from rarer medium to denser medium, its speed decreases. Okay, so whenever light passes from rarer to denser, its speed is going to decrease, and when it passes from denser to rarer, then its speed is going to increase. जैसे suppose this one is glass. Okay, suppose this one is glass. So जब भी light ray एयर से ग्लास में आएगा, सो एयर इज व्हाट? डेंसर, रेयर मीडियम, एंड ग्लास इज व्हाट? डेंसर मीडियम. सो एयर से ग्लास में आएगा तो इसका स्पीड क्या हो जाएगा? डिक्रीज हो जाएगा. ठीक है, और इसका रिवर्स क्या होगा? अगर जो लाइट रे है वो ग्लास से अगर एयर में जाएगा, देन क्या होगा? इसका स्पीड इंक्रीज हो जाएगा. सो दैट वन इज द पॉइंट. नाउ सेकेंड पॉइंट इज व्हाट? Frequency of light does not change on refraction. Okay, so frequency of light is not going to change whenever there is refraction. Means frequency remain same whether it is passes from air to water or water to air or air to glass. Okay, its frequency will remain same. Then third one is what? Wavelength. So as we know that frequency is equal to v by lambda. Lambda is called what? Wavelength, and v is velocity of light. So through this expression we can write lambda is equal to v by f. So here we have seen that whenever light ray passes from two medium, this f is not going to change. Okay, it will remain constant, so f is not going to change. So through this we can see that lambda is directly proportional to v. So lambda is directly proportional to v. So when v is going to increase, lambda is also going to increase. When velocity is going to decrease, lambda is also going to decrease. So what we have learned from here? Suppose कोई लाइट रे रिफ्रैक्शन हो रहा है, ठीक है। सपोज कोई भी लाइट रे का रिफ्रैक्शन हो रहा है, ठीक है। तो इस रिफ्रैक्शन में मेरा क्या होगा, हाँ इसमें देखो ये किस मीडियम से आया, डेंसर से किस में जा रहा है, रेयर मीडियम में, ठीक है। तो वेलोसिटी मेरा क्या होगा, इंक्रीज होगा या डिक्रीज होगा रिफ्रैक्शन के बाद। सपोज ये v1 है, रिफ्रैक्शन के बाद वेलोसिटी क्या है v2, इसमें मेरा λ1 है, रिफ्रैक्शन के बाद सपोज वेवलेंथ λ2, और ये मेरा f1 फ्रीक्वेंसी दिस साइड f2। सो इस केस में डेंसर से रेयर जा रहा है, मतलब जो मेरा वेलोसिटी v2 है वो बड़ा होगा किससे, v1 से, क्योंकि वेलोसिटी क्या होगा, इंक्रीज हो जाएगा, ठीक है। अभी डिस्कस किया था ना कि जब लाइट रे रेयर मीडियम से डेंसर मीडियम में जाएगा तो स्पीड डिक्रीज होगा, एंड व्हेन पासेस फ्रॉम डेंसर टू रेयर इट्स स्पीड इज गोइंग टू इंक्रीज। ओके, सो स्पीड इंक्रीज हो जाएगा, एंड स्पीड बढ़ेगा तो जस्ट आई हैव टोल्ड यू दैट lambda is also going to, wavelength is also going to increase. So again λ2 is greater than λ1, and there is no change in frequency, so frequency remain same. Okay, now let's discuss refractive index. It is represented by mu. Okay, so generally refractive index is, it is optical capacity of a medium to bend the light ray. Means this one is one optical parameter. Okay, ये बताता है कि रिफ्रैक्टिव इंडेक्स अगर किसी ट्रांसपेरेंट मीडियम का ज़्यादा है तो उसमें रिफ्रैक्शन क्या होगा, ज़्यादा होगा, मतलब लाइट रे ज़्यादा बेंड करेगा। रिफ्रैक्टिव इंडेक्स अगर कम है तो उसमें जो मेरा लाइट रे का पाथ है वो कम डेविएट होगा। ओके, सो दैट वन इज रिफ्रैक्टिव इंडेक्स, ठीक है। और रिफ्रैक्टिव इंडेक्स हमेशा एक कंपैरिजन में निकाला जाता है, मीन्स टू मीडियम का, ठीक है। हाँ, देयर इज वन मोर थिंग, absolute refractive index. Okay, so what is absolute refractive index? Okay, when refractive index of any medium defined with respect to vacuum with respect to vacuum, then it is called absolute refractive index. Okay, now let's write the general formula for refractive index. Okay, so refractive index, in short I'm writing mu. Okay, refractive index mu is equal to speed of light in air divided by speed of light in मीडियम, जिस मीडियम से मेरा लाइट रे पास हो रहा है। ओके, सो म्यू इज इक्वल टू सी बाई वी, वेयर सी इज व्हाट, स्पीड ऑफ लाइट इन एयर। वी नो दैट स्पीड ऑफ लाइट इन एयर इज हाउ मच, 3 into 10 to the power 8 meter per second. Now let's find refractive index of some transparent using this formula. Okay, so first let's find refractive index of glass with respect to air. Okay, so I have told you that whenever we are writing refractive index, so we have to find for what, glass. So glass should be right in this dash side. Okay, and with respect to air, so air should be written like this. So a mu g, is equal to, just now I have told you that speed of light in air divided by speed of light in medium. So its speed of light in air is 3 into 10 to the power 8 meter per second, and speed of light in glass, okay, speed of light in glass is equal to 2 into 10 to the power 8 meter per second. So it will come how much? 1.5. So this one is the refractive index of glass with respect to air, 1.5. Okay, now let's find refractive index of water with respect to air. So now again we have to write what? We have to find the refractive index of water with respect to air. Okay, so here again we have to write speed of light in air or vacuum divided by speed of light in water. So speed of light in air 3 into 10 to the power 8 meter per second, and speed of light in water is 2.25 into 10 to the power 8 meter per second. Okay, so 10 to the power 8, 10 to the power 8, it is going to cut and it will come 4 by 3. Okay, so 4 by 3, or it can be written as 1.33. So this one is the refractive index of water. Now this one is the refractive index of glass, and this one is the refractive index of water. Okay, so now tell me, suppose there is refraction will happen in glass and water, so which will bend the light ray more. So this glass is going to bend the light ray more because refractive index is more. Now one more thing you have to remember, that refractive index of diamond, as we know that diamond has high refractive index compared to all other glass and water. Okay, so refractive index of diamond is equal to 2.41. Okay, now one more thing you have to note, that in note you should write that, see, I have discussed that mu 1 2 can be read as what? Refractive index of medium 2 with respect to 1. Okay, so it can be written like this also, mu 2 by mu 1. Okay, in term of velocity, how we will write? v1 by v2. Okay, because here I have told you that air, okay, see, air, first one is air, so we have written the velocity of air, speed of air. Here I have written water, so below in denominator we have written the speed of light in water. So like that, mu 1 2 in term of speed, suppose I write, then I will write v1 by v2. But in term of refractive index, suppose I have to write, then I will write mu 2 by